A battery electric vehicle is a type of electric vehicle that uses chemical energy stored in rechargeable battery packs. BEVs use electric motors and motor controllers instead of internal combustion engines for propulsion. A battery-only electric vehicle or all-electric vehicle derives all its power from its battery packs and thus has no internal combustion engine, fuel cell, or fuel tank. BEVs include bicycles, scooters, skateboards, rail cars, watercraft, forklifts, buses, trucks and cars. Since the introduction of the all-electric Nissan Leaf in December 2010, about 1 million highway legal plug-in electric vehicles have been sold worldwide by mid-September 2015, of which about 620,000 are all-electric passenger cars and light-duty trucks. The best-selling all-electric car in history is the Nissan Leaf, with sales of over 180,000 units worldwide by early June 2015. The Tesla Model S ranks second, with global sales of about 90,000 units by October 2015. Terminology: vehicles using both electric motors and internal combustion engines are examples of hybrid electric vehicles, and are not considered pure or all-electric vehicles because they cannot be externally charged and instead they are continually recharged with power from the internal combustion engine and regenerative braking. Hybrid vehicles with batteries that can be charged externally to display some or all of their internal combustion engine power and gasoline fuel are called plug-in hybrid electric vehicles, and run as BEVs during their charge-depleting mode. PHEVs with a series powertrain are also called range-extended electric vehicles, such as the Chevrolet Volt and Fisker Karma. Plug-in electric vehicles are a subcategory of electric vehicles that includes battery electric vehicles, plug-in hybrid vehicles and electric vehicle conversions of hybrid electric vehicles and conventional internal combustion engine vehicles. In China, plug-in electric vehicles, together with hybrid electric vehicles, are called new energy vehicles. However, in the United States, neighborhood electric vehicles are battery electric vehicles that are legally limited to roads with posted speed limits no higher than 45 miles per hour. Are usually built to have a top speed of 30 miles per hour, and have a maximum loaded weight of 3,000 pounds. Vehicles by type: the concept of battery electric vehicles is to use charged batteries on board vehicles for propulsion. Battery electric cars are becoming more and more attractive with the advancement of new battery technology that have higher power and energy density and higher oil prices. BEVs include automobiles, light trucks, and neighborhood electric vehicles. Rail battery electric rail cars. Locomotives. Electric rail trolley. Electric bus. Chattanooga, Tennessee operates 9 zero-fare electric buses, which have been in operation since 1992 and have carried 11.3 million passengers and covered a distance of 3,100,000 kilometers. They were made locally by Advanced Vehicle Systems. 2 of these buses were used for the 1996 Atlanta Olympics. Beginning in the summer of 2000, Hong Kong Airport began operating a 16-passenger Mitsubishi Rosa electric shuttle bus, and in the fall of 2000, New York City began testing a 66-passenger battery-powered school bus, an all-electric version of the Bluebird TC/2000. A similar bus was operated in Napa Valley, California for 14 months ending in April 2004. The 2008 Beijing Olympics used a fleet of 50 electric buses, which have a range of 130 kilometers with the air conditioning on. They use lithium-ion batteries, and consume about 1 kWh per mile. The buses were designed by the Beijing Institute of Technology and built by the Jinghua Coach Company Limited. The batteries are replaced with fully charged ones at the recharging station to allow 24-hour operation of the buses. In France, the bus electric phenomenon is in development, but we already can find some of them in operation in numerous cities of France. PVI, a medium company located in the Paris region, is one of the leader of the market with its brand Jepibus. In the United States, the first battery electric, fast-charge bus has been in operation in Pomona, California since September 2010 at Foothill Transit. The Proterra ECO Ride BE35 uses lithium titanate batteries and is able to fast charge in less than 10 minutes. In 2014, the first production model all-electric school bus was delivered to the Kings Canyon Unified School District in California unregistered trademark San Joaquin Valley. The Class A school bus was built by TransTech Bus, using an electric powertrain control system developed by Motive Power Systems, of Foster City, CA. The Army was one of 4 the district ordered. The first round of SSTE buses is partly funded by the AB 118 Air Quality Improvement Program administered by the California Air Resources Board. This battery electric school bus has 4 sodium-nickel batteries. The TransTech Motive vehicle has passed all KCUSD and California Highway Patrol inspections and certifications. Although some diesel hybrids are in use, this is the first modern electric school bus approved for student transportation by any state. The same technology is used to power the Mountain View community shuttles. This technology was supported by the California Energy Commission, and the shuttle program is being supported by Google. Thunder Sky builds lithium-ion batteries used in submarines and has 3 models of electric buses. The 10/21 passenger EV 6700 with a range of 280 km under 20 minutes quick charge, the EV 2009 city buses, and the 43 passenger EV 2008 highway bus, which is a range of 300 km under quick charge, and 350 km under full charge. The buses will also be built in the United States and Finland. Free Tindo is an all-electric bus from Adelaide, Australia. The Tindo is made by Designline International in New Zealand and gets its electricity from a solar PV system on Adelaide's central bus station. Rides are zero fare as part of Adelaide's public transport system. First electric commercial bus. Seoul Metropolitan Government runs the world's first commercial all-electric bus service. The Army was developed by Hyundai Heavy Industries and Hankook Fiber, which make a lightweight body from carbon composite material. Provided with Li-ion battery and regenerative braking, the bus may run to 52 miles in a single 30 minutes charge. The maximum speed is 62 miles per hour. First fast charge, battery electric transit bus, Proterra's ECO Ride BE35 transit bus, called the Ecolina by Foothill Transit in West Covina, California, is the world unregistered trademark S first heavy-duty, fast charge, battery electric bus. Proterra's ProDrive drive system uses a UQM motor and regenerative braking that captures 90% of the available energy and returns it to the TerraVolt energy storage system, which in turn increases the total distance the bus can drive by 35%. It can travel 40 miles on a single charge, is up to 600% more fuel efficient than a typical diesel or CNG bus, and produces 44% less carbon than CNG. Electric trucks equals. For most of the 20th century, the majority of the world's battery electric road vehicles were British milk floats. Electric vans equals. In March 2012, Smith Electric Vehicles announced the release of the Newton Step Van, an all-electric, zero-emission vehicle built on the versatile Newton platform that features a walk-in body produced by Indiana-based Utilimaster. Electric cars equals. An electric car is a plug-in battery-powered automobile which is propelled by electric motor, S. Although electric cars often give good acceleration and have generally acceptable top speed, the lower specific energy of production batteries available in 2015 compared with carbon-based fuels means that electric cars need batteries that are fairly large fraction of the vehicle mass but still often give relatively low range between charges. Recharging can also take significant lengths of time. For shorter-range commuter-type journeys, rather than long journeys, electric cars are practical forms of transportation and can be recharged overnight. Electric cars have the potential of significantly reducing city pollution by having zero tailpipe emissions. Vehicle greenhouse gas savings depend on how the electricity is generated. With the current U.S. energy mix, using an electric car would result in a 30% reduction in carbon dioxide emissions. Given the current energy mixes in other countries, it has been predicted that such emissions would decrease by 40% in the UK, 19% in China, and as little as 1% in Germany. Electric cars are expected to have a major impact in the auto industry given advantages in city pollution, less dependence on oil, and expected rise in gasoline prices. World governments are pledging billions to fund development of electric vehicles and their components. The U.S. has pledged $2.4 billion in federal grants for electric cars and batteries. China has announced it will provide $15 billion to initiate an electric car industry. About 620,000 highway-capable all-electric passenger cars and light utility vehicles have been sold worldwide by mid-September since 2008, out of total global sales of about 1 million light-duty plug-in electric vehicles. As of September 2014, the United States had the world's largest stock of all-electric cars, with 116,031 units sold since December 2010, out of about 256,000 plug-in electric cars sold in the country. The Nissan Leaf is the world's top-selling highway-capable electric car ever, with global sales of over 180,000 units by early June 2015. The Tesla Model S ranks second, with global sales of about 90,000 units by October 2015. The Renault-Nissan Alliance is the leading electric vehicle manufacturer with global sales of 250,000 all-electric vehicles delivered by early June 2015, of which 185,000 were sold by Nissan and 65,000 by Renault. Ranking second is Tesla Motors with about 75,000 electric cars sold between 2008 and May 2015, including its Roadster and Model S. Mitsubishi Motors is the third best-selling all-electric vehicle manufacturer, with global sales of over 50,000 all-electric vehicles between July 2009 and early March 2015, including the rebadged variants Peugeot Ion and Citroën NC0 sold in Europe. And over 6,200 Mitsubishi Minicab MiEV all-electric utility vans and trucks sold in Japan through December 2014. BMW ranks next with over 25,000 i3s sold through May 2015, including the Rex models. Special purpose vehicles Special purpose vehicles come in a wide range of types, ranging from relatively common ones such as golf carts, things like electric golf trolleys, milk floats, all-terrain vehicles, neighborhood electric vehicles, and a wide range of other devices. Certain manufacturers specialize in electric-powered in-plant work machines. Two- and three-wheeled vehicles An increasing variety of two-wheeled electric vehicles is being made for transportation and entertainment. These include devices for sitting on such as electric motorcycles and scooters or electric bicycles, as well as devices for standing on such as the Segway Point or self-balancing two-wheeled boards. Three-wheeled vehicles include electric rickshaws, a powered variant of the cycle rickshaw. Technology Motors Electric cars have traditionally used series wound DC motors, a form of brushed DC electric motor. Separately excited and permanent magnet are just two of the types of DC motors available. More recent electric vehicles have made use of a variety of AC motor types, as these are simpler to build and have no brushes that can wear out. These are usually induction motors or brushless AC electric motors which use permanent magnets. There are several variations of the permanent magnet motor which offer simpler drive schemes and lower cost, including the brushless DC electric motor. Motor controllers The motor controller regulates the power to the motor, supplying either variable pulse width DC or variable frequency variable amplitude AC, depending on the motor type, DC or AC. See also: all-electric range, automotive battery, battery balancer, better place, car battery, dump charging, electric boat, electric drive transportation association, electric vehicle warning sounds, global electric motor cars, government incentives for plug-in electric vehicles, GreenPower, list of electric cars currently available, list of electric vehicle battery manufacturers, list of production battery electric vehicles, miles per gallon gasoline equivalent, patent encumbrance of large automotive NIMH batteries, road-powered electric vehicle, short commute vehicles, supercapacitor, Think Global, Tokyo Electric Power, wireless charging. References. Further reading: Witkeen, Jim. Building Better Batteries for Electric Cars, The New York Times, March 31, 2011, p. f4. Published online March 30, 2011. Discusses rechargeable batteries and the new technology lithium-ion battery. External links, alternative fueling station locator, charging stations. Automotive Design Line Europe, Electric and Hybrid Vehicle Design Resource for Engineers and Engineering Managers. Transport Action Plan, Urban Electric Mobility Initiative, United Nations, Climate Summit 2014, September 2014, Zero Emission Workspace, Electric Vehicles in an Off-Grid Commercial Building Project. Patents, U.S. Patent 523354, Emil E. Keller, Electrically Propelled Perambulator, 1894, U.S. Patent 594805, Hiram Percy Maxim, Motor Vehicle, 1897, U.S. Patent 772571, Hiram Percy Maxim A.L., Electric Motor Vehicle, 1904, Organizations, Battery Vehicle Society and EV Network Euro, the UK National Directory of Recharging Points. The European Association for Battery, Hybrid and Fuel Cell Electric Vehicles. Evanida Euro promoting the uptake of electric vehicles in Canada. Czech EV Club a Euroing section in Photogalery. Alternative Technology Association Electric Vehicle Interest Group. Australian Electric Vehicle Association. Electric Car Society. News, reasons to buy an electric car in 2013. AeroVironment awarded U.S. patent for electric vehicle energy data management and control, solar charging station for Ford Focus electric vehicle, studies, application of life cycle assessment in a no-scale technology, lithium-ion batteries for electric vehicles, U.S. Environmental Protection Agency, April 2013. Hybrid and electric vehicles, the electric drive gains traction, IAHEV, International Energy Agency, May 2013. Will electric cars transform the U.S. vehicle market? Belfer Center, Harvard University.